When we're multiplying matrices, there's a few things we need to consider first. The first thing is the multiplication defined? Are we allowed to multiply these two matrices? The second thing is, what is the answer matrix? What does it look like? What is the order of it? So let's have a look at how to do that. When we're checking if it's defined, we look at the columns of the first matrix and the rows of the second matrix, and we need them to be the same. If they're not the same, then you cannot do that multiplication. Our answer matrix is going to be the rows of the first matrix, the column of the second matrix. I would always start with that before I actually go and do the multiplication. So now let's look at actually multiplying two matrices. How do we do it? Now it's always going to be rows by columns. So remember that. Let's just check that this multiplication is defined. So we have a 2 by 2 and a 2 by 2. Our answer will be, let's just check, they're the same, great. And our answer will be 2 by 2. So the first step, the first row and the first column. 1 times the 5, so 1 times the 5 there, plus 2 times 7. That will give us the first element of our answer matrix. Now we've done the first column, we're going to move to the second column. So stick with the first row, but let's move on to the second column. 1 times 6 plus 2 times 8. Now we've done all the columns, so we now move on to the second row and the first column. 3 times 5 plus 4 times 7. And lastly, again, same row, so the second row, but we're moving on to the second column. 3 times 6 plus 4 times 8. And then we just have to evaluate those numbers and we get our answer matrix. So for example, we'd have 1 times 5 plus 2 times 7, so 5 plus 14. That's going to be 19. 1 times 6 plus 2 times 8, that's 16, and 6, 22, etc. And then you do the last two. Now notice that when we did the first row and the first column, the answer was put here, first row, first column. If we wanted to figure out where did this come from, well, that's in the second row, first column. So it came from the second row, first column. And understanding that can be helpful answering like multiple choice questions in an exam without having to do the entire multiplication. Let's do another one. Okay, first let's just check that this multiplication is defined. So we have a 2 by 3 and a 3 by 2. Our answer matrix will be 2 by 2. And this is defined because we have those numbers being the same. Let's start with first row, first column. 1 times 7 plus 2 times 9 plus 3 times 11. Let's move on to first row, but second column. First row, second column. 1 times 8 plus 2 times 10 plus 3 times 12. Okay, we've done all the columns. Let's move on to the second row. Second row, first column. 4 times 7, 5 times 9 plus 6 times 11, etc. Okay, I'm going to move on and we're going to do a question where there's an unknown. not in our answer. We're not trying to find the answer, but we're using the answer to find an unknown in the question. We do not have to do this entire multiplication. What you can think about is, well, I know that multiplication works by doing first row by first column gives us first element. So I can construct an equation out of this. I know that 10 is made up of a times 1 plus 1 times 5. Let's solve that equation. A times 1 is just a, 1 times 5 is 5, therefore a must be 5. Well, we found a, we don't really need to do anything else. We could have found it using the 28. So 28, that's first row, second column, first row, second column. We could have said 28 is made up of a times 4 plus 1 times 8. And we could have solved that. But I think the first one was easiest because we've got ones. We're working with ones there. All right, multiplication can also be used to sum rows or columns. So let's look at the first situation. If we want to sum the columns, that means we want to add up everything in each column. Then we need to pre-multiply by a row of ones. Now, pre-multiply means we're multiplying before our matrix, and we put the number of ones that we put in that row should equal the number of rows, because you're going to be multiplying row by column. So if I was to do this, 1 times 1 plus 1 times 3 plus 1 times 5, you can see it's just adding 1 plus 3 plus 5, 9. So that's going to be 9 there. And then we do that same row, but multiplying the second column is ultimately just adding that up. That's going to be 12. So to sum columns, pre-multiply. I like to think of columns, in Roman architecture, it's in the past, so it goes before. It's from before times. If we want to sum the rows, so sum that row, we post-multiply by a column of ones. This times this is essentially just adding up the 1, 2, 3. So again, that's it's going to be 6. And multiplying this by 1, 1, 1, we get 4 plus 5 plus 6, 15. Okay. Now, notice that whatever this looks like, we have to choose the appropriate number in our row or column when we multiply. So you'll have to think about that a little bit to make it work. Let's look at this question. What if I want to sum the rows? So I want to add all of those together. Summing rows, I post multiply by a column, but how many ones are in my column? Well, I need to have it match the number in this row. So I've got 5 there, so I need 5 ones. And it needs to be post-multiplied. And you can always just check, does that work? 3 by 5, multiplying a 5 by 1, my answer will be a 3 by 1. So each row will be the sum of the row of my original matrix.